going to present to you an abridged edition of a position paper that I submitted. We are members. I'm a member of the Amici della Pontificia Accademia Pro Vita, the Pontifical Academy for Life of the Vatican. We are before they commit annually or special meetings or a special issue, they gather opinions from the Amicis, the friends. They call us the friends of the Pontifical Academy for Life, and then we send them position papers on specific matters. And lately, it's about gene editing. I will not dwell on the science of gene editing. It's complicated. Anything complicated is difficult to understand, especially when it involves a little complicated science. But I will dwell on issues and concerns and the ethics of gene editing. This case became a topic for the Pontifical Academy because of the case of Brian MADEUX. I don't know if you've heard him. He was the first to receive gene editing in the United States. This is the Brian. He's 44 years old, has MPS 2 and Hunter syndrome, a rare disorder that causes progressive damage to the body's cells. So, currently, there's no cure yet to MPS 2. If you will have Hunter syndrome, you'll have hearing problems, bone joint malformation, and of course, heart and breathing difficulties, widespread damage of the body, leading to shortened lifespan. So it's quite a surprise that Brian reached the age of 44 with Hunter syndrome. It's in itself a miracle for him. Now, it can be managed and treated today, but it can only be managed, but it cannot be resolved by enzyme replacement, therapies. But the good thing is it's a monogenetic disease, so it means that with gene editing, it's easy to do. Now, on last November 13, 2017, Brian received an experimental in-body gene editing treatment in the United States. A gene editor was introduced through an IV into his bloodstream along with copies of a corrected gene to replace the mutation he carries that is responsible for the Hunter syndrome or disorder. Now, he's taking part in a study in the United States, the Sangam study, of trying to determine whether gene therapy is safe and effective to humans. Although the therapy itself has not yet been approved by the US FDA, but experimentation is already ongoing, and Brian MADEUX is is the first volunteer for this study. Well, he said it's a privilege for him to volunteer, whatever the effects may be, but he accepted the reality that he may survive and he may not survive. Okay, but last February 6, it was reported by AP that there's another person who received gene editing therapy. They did not reveal the name because he wouldn't like to be known, not even the place, but he received gene editing therapy in California. Okay, his identity held confidential. Why? Because after 3 months, they observed no side effects on Brian, so they allowed the second patient to receive the gene editing therapy. Now, they said he's doing well according to the report, but it's too soon to know whether the treatment worked. Still have to wait. So what is gene editing? Just for us to know, some of you already probably know this, but gene editing is part of the technologies that give scientists the ability to change an organism's DNA. It's under genetic engineering. These technologies allow genetic material to be added, to be removed or altered at particular locations in the gene. Especially, several approaches to gene editing have been developed today. Now, with gene editing, researchers can now disable target genes, correct harmful mutations, and change the activity of the specific genes in plants and animals, including now humans. So you can correct DNA, delete if you want to, insert for improvement, or to alter it, and excise it, to remove it. Okay. Now, one of the famous gene editing now, and it's a little bit controversial, because of what Chinese scientists did. This is the CRISPR case now. You'll get to know this later. Never mind that one. Okay. So these are the current ones, the CFN or finger nucleus therapy, the TALENS therapy, and the famous CRISPR case like CAS9. And here's a table of what is it, and what are the pros and cons of the following editing options. Now, what did Brian MADEUX receive? Brian received the CFN, but not the CRISPR. The CFN, the finger nucleus technology. Now, where they cut using zinc, the science, they cut the DNA to replace it with corrected ones, and then hopefully it will be, it will correct the genetic disorder. But they cannot still predict the effects. Okay, what are the possibilities of gene editing? I'm skipping the science of it. Of course, if it works, it will be a good thing for public health, and the management and delivery of healthcare will be. Just imagine you can already cure genetic diseases by just correcting, altering the DNA, and correct genetic maladies. So whatever genetic malady or sickness we have today can no longer be passed on to the next generation. So it spells probably the end of genetic diseases if this will be successful. And of course, improvement of the human race. It's a little bit I don't know if we can improve the human race. And preventing of debilitating diseases and unnecessary pain and suffering. Okay. Can benefit parents, of course, by enabling them to have healthy children who are genetically related to them. It can benefit society by reducing the social and economic burdens of genetic disease. Society can also benefit from it if it is used for enhancement of human traits that can increase human knowledge, productivity, performance, aesthetic experience, and other social goals. It can benefit the human gene pool by enabling society to promote good genes and rid of the bad ones. But what are the boundaries? How do we know whether a particular gene editing technology is acceptable or not? Well, there are some boundaries that we need to consider, and these boundaries are also boundaries of genetic engineering. First is we have to identify whether it is a therapy or enhancement. We know for a fact that enhancement is not yet allowed. And therapy is allowed. But what kind of therapy? Is it somatic or is it germline? So the boundaries. So we have somatic gene editing for therapy, somatic gene editing for enhancement, germline gene editing for therapy, and germline gene editing for enhancement. So gene editing can be somatic or germline, can be therapy or for enhancement. Now, SGET, somatic gene editing for therapy. The goal is to disable target genes, correct harmful mutations, and change the activity of specific genes in humans in the somatic level. So, since it targets somatic cells, it probably will not be transmitted, it will not transmit genetic changes in the future generations, as a result of the fact that the genetic inheritance in human beings occurs through germ cells, not in somatic cells. So, if you are corrected and you get married and you have sons and daughters, they will not be carrying the corrected gene because it is the somatic level. GLGET, on the other hand, the germline genetic editing for therapy, the goal is not necessarily to correct diseases, but to modify or enhance an individual so that it carries no genetic mutations or genetic diseases in the germline level. So this is done mostly in the embryonic stage. Now, because GLGET targets germ cells, it is likely to transmit genetic changes to future generations. If I correct you, alter you, and you have a son or a daughter, they will carry the correct one. It's likely that they will carry the genetic change. Okay. On terms of SGEE, this is done for enhancement purposes. Somatic gene editing for enhancement purposes. The goal is to alter not disease processes, but the normal workings of the human body and psyche, to augment or improve their native capacities and performances. So it can create superhumans, so things like that. So SGE may improve an individual's capacities and behaviors. Since it targets only somatic cells, changes will not be passed on to the child in case the individual reproduces. With CRISPR-Cas9, this is already near possibility. And Chinese scientists have already experimented on an embryo, editing it to make it farrow. And then the GLG editing for enhancement. The goal is to affect future changes in the human race. The changes created by germline enhancement would affect all future generations, not only the individual treated. Now, in April 2015, Chinese scientists published the first reports of genome modification experiments carried out on human germline cells. And the scientific world is divided. Whether we are ready for it or not, and whether it's ethical or moral. Okay, so there are unknowns. That's why many scientists are little adamant in accepting the germline enhancement or even somatic enhancement because of the unknowns. Well, we know the unknown is dangerous. The effects of SGET on Brian MADEUX and the second patient cannot be quantified or even qualified yet today. Observations are still going on, and it is very difficult to evaluate or assess long-term benefits and risks. How long will they wait? They do not even know. How many months or years? They do not even know. Some of their questions are, will the virus trigger an immune system attack? Just like what happened with the kids who received genetic modification before. Many of them died because of immune system attack. Second issue is, will it affect other genes and trigger other genetic disorders that are not yet in existence today? Okay. Third question is, will it eventually affect the germline? Even if it's somatic, will it eventually affect the germline? Can it mutate into a virus that can penetrate the boundary of somatic and germline? So, another thing is, you only, according to the scientists who did the treatment of Brian MADEUX and the second patient, there's only a one-shot therapy. You cannot have it again. If it fails, you cannot have it again. The reason is it can no longer have an effective delivery system because the body will become immune to the virus. So it's only one shot, once you make a mistake. And the editing is mistake. That's it. Of course, the precautionary principle cautions us with the unknown. If it's an unknown thing, a reality, you have to be very careful, if not suspend action until certainty, at least a certain degree of certainty is established. Now, some of the questions that were asked from us is on ethics. Are we going to accept gene editing for somatic therapy, for therapy, or are we going to accept gene editing for enhancement? Now, somatic GE for therapy seem to be permissible, since only the individual is affected and cannot be transferred to the next generation. So future changes will not occur. The change will only occur to the person. And it's for disease control purposes. SGEE, on the other hand, it's objective, run contrary to treatment or therapy. It's not about treating, it's not about therapy, it's more on enhancement. So also with GLET and GLGEE, they are considered unethical since their aims are to alter the human genetic line, and changes made are inheritable, can be transferred to the next generation. Now, some scientists, and some of their writings were published in Nature, they believe that it can cause biological harm to patients that result from unforeseen and unpredictable genetic defects. It can also cause psychological harm to patients who may view themselves as products of their parents' desires, as mere commodities, especially when it is on enhancement. Now, GLET and GLEE could cause harm to a mother who carries a genetically modified child. It might carry an increased risk of preeclampsia, for example, or complications during labor and delivery. This is one of the things raised during the hearing of gene editing in the US, the possible effect to a mother who carries a genetically modified child. GLGET and GLGEE could harm future generations also, because some genetic defects may not manifest themselves until the second generation. So it's difficult to wait for the effects to be seen. It may be difficult to estimate the potential harm to future generations. It could harm the gene pool by reducing genetic diversity. It could waste healthcare resources that could be better spent elsewhere. And it is a big pursuit of human perfection, others say. Now, it can cause harm to society. Some say it can increase social and economic burden carrying patients with genetic defects caused by GIGE, especially the genetic disease that was produced because of enhancement. It's a disease that we don't have any cure for it yet. It could violate the rights of children, for those defending the rights of the child, including the right not to be harmed, the right to an open future, and of course the right not to be subject to an experiment, especially if it is embryonic enhancement. It may cause social injustice by increasing the gap between the genetic haves and the genetic have-nots. What if your friend is genetically altered and enhanced and you are not? You perform better than he or she performs better than you in other aspects. Some countries, especially in Europe, for example, the danger is real. They ban germline research. Others, such as China, for example, have guidelines described as unenforceable. Britain allows basic lab research only. In the US, the NIH don't fund research involving germline editing, but they allow it if it's privately funded. So you can have germline research if it is privately funded. Now, in February of this year, the Human Fertilization and Embryology Authority of the United Kingdom approved requests from a laboratory, Francis Crick Institute in London, from the institute, to modify human embryos using the new gene editing technique CRISPR-Cas9, just like what Chinese scientists did. And I think they began the research already. The ISSCR, International Society for Stem Cell Research, urged scientists across the world to temporarily suspend any research related to human germline genome editing. So, to get the pulse of the scientists, the Science Advisory Board in 2015 did a survey to scientists working on genomics if they thought that we should move forward with human germline editing modification. This is prior to the Chinese research and after the Chinese research. Before the Chinese research was published, most say we should not pursue germline gene modification. That's 52%. But after the Chinese scientists published their work, only 28% of the survey said we should not pursue. Many of them now say we should, or at least open the possibility that it can be done. But still, what prevented them from pursuing the research are ethics questions and moral questions. Should we tinker with the human genetic makeup? And so some questions. Should we ever move forward with human germline genome editing? Majority of the scientists say yes, 61%. We should move forward. Of course, they say it's our moral obligation to improve the human genetic pool. But 39 said no, let nature do its work, and among other reasons. And then when they were asked, should we hold a moratorium on human germline genome editing? Many of them said yes. It's a little conflicting. They want us to move forward, but they said we should have a moratorium on human germline genome editing. 70%, so majority of them don't want to edit yet. Moratorium, stop to the research on germline genome editing. 30% said no, we should proceed. So why not? Okay. And the statement made by the National Academies of Sciences, Engineering and Medicine in 2015, after the Chinese scientists published their work, there was a summit on human editing in 2015, and these are the things that the issues that they presented. Germline editing poses many important issues, including the risk of inaccurate editing, because in zinc, CFN, and even in CRISPR-Cas9, the editing cannot be accurate. Sometimes it cuts a different part of the DNA. It's a mistake in cutting of the DNA and in the inserting of the altered DNA. So until scientists can ascertain that the cutting of the DNA is accurate and precise, they say we must have a moratorium on the researches. The difficulty of predicting harmful effects that genetic changes may have under the wide range of circumstances experienced by the human population, including interactions with other genetic variants and with the environment. Third is the obligation to consider implications to the individual and future generations who will carry the genetic changes. The fact that once introduced into the human population, genetic alterations would be difficult to remove and would not remain within any single community or country. The possibility that permanent genetic enhancements to subsets of the population could exacerbate social inequities or be used coercively. Social inequities like, for example, of course, funding budget, and of course the genetic health, and of course the moral and ethical considerations. So the Academy said it would be irresponsible to proceed with any clinical use of genome editing unless and until first, the relevant safety and efficacy issues have been resolved, and second, there is a broad societal consensus about the appropriateness of the proposed application. So we should only proceed under appropriate regulatory oversight. And then, speaking of regulations, we know, Oviedo Convention, Article 13 says, an intervention seeking to modify the human genome may only be undertaken for preventive, diagnostic, or therapeutic purposes, and only if its aim is not to introduce any modification in the genome of any descendants. And this has not yet been revised. And the UNESCO, following the Oviedo Convention, with its declaration of human genome, endorses the notion of the preservation of the human genome as a common heritage of humanity, so we should not tinker with it. I have questions. I sent these questions to the Academy. Who gets to decide what is an improvement to the human genome? Is it the patient, the scientific community, the father, the mother? Will it be the church? The questions of equity and justice. Who can access the technology? Those with money. So those who are poor, the technology is expensive, will remain the genetic have-nots, while those who can afford it will be the genetic haves. And of course, the commodification of the human race is an issue. And not everything that is technically possible is ethically permissible. So I end with this one. The UNESCO IBC report, this is, I think, late last year or this year, updating its reflection on human genome and human rights. This is the latest photo. Gene therapy could be a watershed in the history of medicine, and genome editing is unquestionably one of the most promising undertakings of science for the sake of all humankind. But they still ask for a moratorium to germline editing. We can have the therapy, but we don't have the enhancement. Okay. So just a glimpse of the issue at hand. The Academy will meet 2 months from now with the scientists and the Nobel Prize winners, and they will release a report document on gene editing as requested by the scientific community. It's dinner time.
Thank you, Marlon. Questions? Mayashi, please use the microphone, please. Hassan is waiting from last time.
I think you were microphone.
Please.
Oh, I'm talking about microphone. Yeah, I mean, thank you for the informative presentation. I have a personal question to you. I mean, you started by talking about the Vatican or whatever. What is the position of the church on these gene editing ethical issues you presented?
Yeah. In the document, I forgot the name of the document. No. Dignitas Person. the fetus person. It's okay for them if it is therapy. But if it is an enhancement of the germ life, they don't allow. For them, you are tinkering with God's will. It's God's creation. You can tinker with the human genetic line, but you can have therapy as long as it cannot be transmitted to the next generation. That's their position. But with the gene editing now, I don't know what will happen. But as of in terms of genetic engineering on humans, they don't allow it when it is enhancement, like but if it is therapy, it's okay. Somatic therapy, but not germline therapy. That's also the differences. So they define the boundary between germline and somatic. Germline because there's a possibility that it can be transferred to the next generation, and for them that's a little problem. If it is somatic, it only affects the person who was treated. It cannot be transferred to the next generation, the altered gene or DNA. So the progeny is protected, your heritage is protected.
Other questions or comments?
Yes.
Yes.
A question and a comment. I'll start with the comment first. Based on everything I've learned so far about gene editing, and this was during classwork with Daryl last year, and now this is amazing. Thank you very much, actually. I was so excited actually when I learned that you were presenting today, so it made me want to not miss it. So the comment is that there's a lot of people now in the scientific community who are interested in this topic who feel, and this may be due to the quantum effect of the Chinese work, who feel that there's nothing natural or there's nothing statistically natural about nature. We just take it for granted that we represent nature. But I underline the word represent, as Daryl commented on my talk earlier. What if we are only a representative of nature? And that means this is the best that nature can do, and what's wrong with enhancing this representation of nature? What's wrong with enhancing the representation of the people? What's wrong with enhancing the representation of the stable? What's wrong with enhancing the representation of our understanding of our genetic order? So to me, this is something that, yeah, touches on bioethics, but if we look at it this way, maybe will make it less, sort of less sinful, to use, for lack of a better word, and make it maybe more something that will encourage more people to think, what's wrong with that? What do you think?
Actually, I think the prohibition is only in humans. We've been altering animals and plants since genetic engineering was invented.
Yeah.
I have the privilege of, seeing how the tilapia, the St. Peter's fish was altered, and now we have a super tilapia. I've seen a lot. We were there when the laboratory, put together different DNAs from different varieties of tilapia around the world and created this new big one. But it doesn't taste good, I'm telling you. I ate one. It doesn't taste good. Yeah, among animals and plants, I think we don't have a problem with it. No? We alter the soybean so that we can remove the allergen in the soybean. But among humans, I think we are very protected with the human gene pool. We are very protected.
Yeah.
The idea of one of the things that I see from even the documents of IBC when they deliberated this matter is the underlying idea is one is justice, justice. That's one of the things they always reiterate, the justice. That the privilege will have more privilege again in this technology, although I don't see the problem now. And those who can will remain those who can, and they will never have it. Another thing is the idea of it's still injustice is the uneven field in competition, social implication, like you will be employed while this not genetically modified will not be. If you perform well than him, you will be a priority. The problem again of profiling of people, like where is your genetic record, where is genetic data before you are employed, before you be given a particular service, things like this. These are the things that they are offensive about. So another one is, well, you said nature is seen to be questioned now. That is there such a thing as nature among things?
Exactly.
Yeah.
Yes.
But this in bioethics, we still anchor on the idea that there is something in nature that limits even the application of technologies. One of which is the human patrimony. Okay. Another one that I see from even in the document in Dignitas Personae, or even in the human genome document in IPC is, aside from justice would be, going back to autonomy. If I alter the child, since the child cannot give consent, the embryo cannot give consent, he will be participating, he will be the embryo will be subjected to a procedure that on the first place you will never know if he likes it or not. So it limits, that's one of the unknowns. It limits the application. Those are the things. But if you ask me, will I approve of enhancement? Will I recommend it? Will I have scientists do the enhancement? The present state of research? No. The precautionary principle tells me I should not, because even then they cannot predict the effects. Even with Brian, he was so brave to undergo the treatment, but the doctors can never explain to them what will the effects be. So they are experimenting on something that they can even predict what will happen in the next 5 months, 2 years, 5 years. So we are waiting. If he dies, then we know you die when you do a gene editing. Just like what happened to the kids who receive a genetic treatment. What's the sickness? There were 12 young kids, 9 of them died because they developed leukemia as an effect of the genetic treatment. So things like this. So at the present state of research, I will not, unless otherwise the scientists will give us a certain degree of certainty that it is actually good and it does not have these effects.
Okay.
At the present state of research, I don't.
Thank you.
Thank you very much, Marlon. Thank you.